Hello, Year 9. This is for the 3B textbook within the 10D chapter, and that is on constructing equations. Okay, so in this chapter you'll find some real-world examples of something. So every day you're going to come across someone that might think of a number that you have to then figure out. Not the best example to start with, but we will carry on with this. Okay, so Hassim thinks of a number, x. He trebles it, he subtracts 4, and then he doubles the result. His final answer is 4 times its original number, x. Find the value x. Okay, so what we have to do is we have to construct our equation first off. So I'm going to use each of these in stages. Okay, so we did this a little bit last time, but we're just going to look at this in stages. So I know that my original number is x. So I'm going to just write an x down to start off with. Okay, to treble something, that means we're going to triple it, so we're going to times it by 3. So that is now 3 times x, and we usually write that as 3x. Okay? That's better. And then we're going to subtract 4. Okay, so from 3x, we subtract 4. Right, so after all that's happened, we then double that result. Okay, so we're going to double 3x subtract 4. Okay, so this whole thing is going to be multiplied by 2. That's what it means to double. Okay, so we need to pop brackets around it, and we're going to multiply that by 2. Okay, please remember that there is a tiny little multiplication sign in the middle of these. Don't need to write it in, but that is what is there. Okay, just rub those out because you don't need them. Okay, so then we know that that is his final answer is 4 times his original number x. Okay, so if that's 4 times his original number, we know that his original number was x. And to do 4 times that, we just write 4x. So that is 4 times x, 4 multiplied by x. Okay, now this should look like a similar question we've seen before. So to solve this, we should know that we have to start with multiplying out our brackets. Okay, don't need to, there are other ways of doing it, and the textbook doesn't. The textbook does do it this way, sorry, so we'll do it the same way as the textbook. Okay, so multiply out our brackets. So we have 2 times 3x, that's 6x. 2 times -4, that is -8. Okay, so 6x subtract 8, and nothing has happened to 4x just yet. Now we have a problem with unknowns on both sides. So to deal with this type of problem, we look at which x term has the lower number in front of it. Again, be really careful with the negatives. That's that one. Okay, so we are going to subtract 4x from both sides. Okay, although this doesn't have an addition sign in front of it, it's still positive. So if we subtract that, it's going to get rid of that on this side. Okay, so we're going to end up with 6x subtract 8, so that's just on that side, subtract 4x is equal to 4x subtract 4x. Okay, nothing else on that side. So now we look for our like terms, so we can collect our x's. So 6 lots of x subtract 4 lots of x is 2 lots of x. Nothing happens to this subtract 8, so we just leave it as is. Okay, we then have 4x subtract 4x, so if we have 4 lots of something, subtract the 4 lots of the same thing. They cancel each other out, so we're left with 0. 0x is just 0. 0 lots of anything is just 0. Okay? Now what I'm going to do is we're going to look at a function machine. So you don't need to use a function machine to solve this one. You can just rearrange it. I'm going to use a function machine, however. So we're looking for x, so we always start with x. Then what we're going to do is think about what's happening first. So we've got a subtract 8 and a times by 2. So if we think about BIDMAS, so order of operations, what's happening first? So we've got our multiplication and we have a subtraction. Okay, so we're going to multiply first and we're going to subtract second, and that is going to give us 0. So if we start at 0 and go back the other way, the opposite, the inverse operation to subtracting 8 is to add 8. then the inverse operation of timesing by 2 is to divide by 2. So to undo multiplying by 2, we have to divide by 2. And that's going to give us our x. So if we start at 0 and we add 8, we get 8. And then if we take 8 and we divide by 2, that is 4. So 2 goes into 8 4 times. So 8 divided by 2 will give you 4. So your answer for this one is x is equal to 4. Okay. The second example on this chapter then, it asks you to find the unknown value of x for these angles. So the quadrilateral has one right angle. It has two equal angles that are x each. We can see that on the diagram. There's our right angle. I haven't drawn that very well. But that's our right angle there. And the fourth angle is 60 degrees bigger than x degrees. Okay, so if we have x degrees, 60 bigger is x plus 60. That's where that's come from. Okay, so bigger just means you add it on. If we're not familiar with this, we should be, but if not, that is a little square. So a little square in a angle means that that is a right angle. Okay, you should be familiar with that. Right then, so where do we start? Okay, well, I know that in a quadrilateral, so a four-sided polygon, we have 360 degrees, okay? I'll explain how we know that. So all of these are going to add up to 360, okay? If I have a quadrilateral, okay? So that is a shape with four straight sides. I can split this into two triangles, okay? So we know that the sum of the angles in a triangle is 180 degrees. So 2 lots of that is 360. That is the same for any quadrilateral. Okay, so there's another 180 degrees, 180 degrees. So the sum of our interior angles for a quadrilateral is the sum of interior angles for a quadrilateral is equal to 360 degrees. Okay, that is always the case for a four-sided polygon. Okay. Right, so we can say that all of these added up. So we know that this is a right angle, so that means that that is 90 degrees. That is what a right angle is. We all know that. So we've got 90 degrees. We also have this x, so this unknown angle, that's x degrees. We've got another one at the bottom there. Sorry, my hand's in the way. We've got another one at the bottom there, x degrees, and then we have x plus 60 degrees. Okay, so x degrees plus 60 degrees is what we have at the bottom there. Okay, and we know that the sum of our interior angles, so when they're all added together, that is 360 degrees. Okay, nice and easy. Then what I'm going to do is I can see that I have all of these x's, so we can collect our like terms. So we have in total 3 lots of x. Okay. We then have a 90 and a 60. So 90 and 60, they can just add together like normal. So we have 150 there, and that's still equal to 360. Okay. I'm going to jump into my function machine, but you can just do it by rearranging, I don't mind. Sorry, we start with our x because that's what we're trying to find out. That's the unknown this time. So we are, what we're doing to our x this time, so we have a multiplication and we have an addition. That's handy. So there's multiplication, there's addition. Multiplication comes first, so we're going to multiply by 3 here. We then have our addition, so we're going to add 150. That is going to give you 360, so we can work backwards from there. Okay, so 360, our inverse of adding 150, so the opposite, how to undo that, is by taking it away. Then we're going to undo our multiplying by 3, so our inverse of multiplying by 3 is divided by 3. And that's going to give you whatever x is. Okay, so 360 subtract 150 is 210. Then 210, 210 divided by 3, a little bit trickier, that is going to be 70. So I would ignore that 0 on there. What's 21 divided by 3? You know that's going to be 7. So just pop the zeros back on and there you go. Okay, so x is equal to 70 degrees. Okay. It doesn't ask you to calculate that one. So that is your final answer. X is equal to 70. So in the final example on this for this chapter, you will find a brick wall where each brick is the sum of the 2 bricks below it. Okay, so not the most real world example, but it's quite abstract and a nice way of getting your head around what is going on here. Okay, so we need to think about what is happening on this bottom row to give us this top row. Okay, so for this one, I think we'll start with, so for this one here, what we're going to do is we need to add the 2 below it. Okay, so that'll be this one and that one. Okay, so to find this one, we're gonna add these 2 together. Okay, so I'm going to draw some arrows in, okay, just so we know which ones we're talking about. So we know that x plus 7 is going to be just, I think that might actually just be x plus 7. Okay, nothing too tricky about that one. That is all that you have to do. Okay, so x plus 7. There's no like terms, there's nothing that's the same, so we don't have any more x's and we don't just have any more units either to add together. So it's just x plus 7. Okay, this one here, we have 3x plus 7, so that's the 2 underneath, these 2, and then that is just going to be 3x plus 7, because we don't have any extras there. Okay, we don't have any like terms, we don't have any more x's, and we don't have any more unit terms. So that one is just 3x plus 7. Right then, so this one at the top, let's have a look at this one. So we have these 2 underneath it. So we have x plus 7, and then we're going to add 3x plus 7. And this time you'll notice that we have 2 x terms and we have 2 units terms. So our 2 x terms is this one and this one. So we have 1 lot of x plus 3 lots of x. So in total we have 4 lots of x, that's 4x. And we have these units. So we're adding 7, and we are adding 7. Okay, so in total we are adding 14 to that. Okay, so that there is just 4x plus 14. That's as easy as that question is. Okay. For the second part of this question, it asks if the value of brick P is 6 times that of brick Q, find x. So this is where the constructing the equation comes into it. Okay, so they've labelled that this one is Q and this one at the top is P. Okay, so if the value of P, so we know that P is 6 times that of Q. Okay, so I've just paraphrased that for you. We need to find x. Okay, so we can look at P is here. So 4x plus 14. And we know that that is equal to, so we know that this one's 6 times bigger. So that means we need 6 lots of this one to be the same as P. Okay, so Q is x, and we know that P, so 4x plus 14 is 6 lots of 6x. Okay, 6 lots of x, sorry. Right, so now what we're going to do is, like we usually do when we've got unknowns on both sides, we circle the one with the smaller value in front of x. So that is this one. And then we subtract it from both sides. Or we remove it from both sides. Be careful with negatives. Obviously that will change what you have to do to get rid of it. So to get rid of 4x we need to subtract 4x from both sides. So that'll give you 4x plus 16 subtract 4x is equal to 6x subtract 4x. Okay, nice and easy. We have 4x and 4x, and that's 16. 4x subtract 4x, so 4x subtract 4 lots of x, that's going to give you 0x, so you're just going to leave left with 16 on this side. That's what we wanted. Then on this side, we're going to end up with 6x subtract 4x, so we know that they both have x's, so 6 lots of x subtract 4 lots of x, that means we've got 2 lots of x left. Okay, so now what you can either do, the quicker way of doing it is just to divide straight through by 2. You're more than welcome to do that. However, we've been using our function machine, so I'll start with that. So we don't know what x is. We are multiplying x by 2, and that's giving you 16. Okay, so we start at 16, and to undo multiplying by x, we divide by, multiplying by 2, we divide by 2, and that will give us whatever x is. Okay, so 16 divided by 2 is 8, so x is equal to 8. Okay, with this bit here, you may have wanted to, so that's not in the form that we're used to, so you may have wanted to change that into 2x is equal to 16. They mean the same thing, it doesn't matter which way around you write them. Okay.